Well, I guess I got a calculator right here. All right. We have just a lesson today and a lesson on Monday, and then a review day and a test on Wednesday next week, so that you know that that's coming down the pipe. Be sure to get any assignments done. All right, today we're talking about tangents. We want to be able to use tangent lines, tangents to circles to solve for missing lengths. And this is, I think, probably one of the most important things about circles and lines. This is probably the most important thing. So a tangent, the word tangent literally translates to touch. And so a tangent line, T-O-U-C-H. Okay, so tangent means to touch, okay? And so a tangent line is excuse me, a tangent line just touches the circle. And so you can see here we have our tangent line AB, and it is just touching the circle, and it touches in one single point. It intersects the circle at exactly one point called the point of tangency. And that's really important. So it touches at one point. A line is tangent to a circle if and only if it is perpendicular to a radius drawn to that point of tangency. So that's really important. In fact, anytime you draw a tangent line, a line that, oopsie, I just missed, a line that just touches your circle at one single point. So if I've just drawn a tangent line, then I can draw a radius to it, and that radius will always be perpendicular to that line. All right? And that's really important. We can do a lot of stuff knowing that we have perpendicular lines. First of all, we have perpendicular, so I'm thinking right angles. If I have triangles, I'm thinking Pythagorean theorem. But I'm also thinking about slopes of perpendicular lines. Okay, parallel lines have what kind of slope? Same slopes. Perpendicular lines have opposite reciprocal slopes. Yeah, so there's a lot that goes on when we know that we have perpendiculars, okay? But not so much for you guys here today, but a little bit. I don't want to really determine if that, we're going to skip right down here. So number 3, if JK is tangent to circle L, find X. So they're telling us that JK, segment JK is tangent. And if it's tangent, then I know that it has a right angle from the radius to that tangent line. So I have a right triangle. And I want to find this length X. What can I do? Pythagorean theorem. Yep. We have a right triangle, so leg squared plus leg squared equals the hypotenuse squared. So 7 squared plus 19 squared equals that X squared. Let's see, I don't know. Wowza. If you ever are like this, you can clear your memory. There's a memory button. It's in blue, so follow along. Really important, actually, because, I don't know, so we're going to do blue and memory, and then you want to reset the memory, so that's number 7. You want to reset all the RAM, number 1, and then just checking, yes, reset it, number 2, and it'll clear all the crap that's in there. So 7 squared plus 19 squared is 410. And then how do you get X by itself? Square root both sides. X equals, let's see, the square root of my answer is 20.2-ish. All right. What about number 4? Again, JK is a tangent line, which means there is a right angle from the radius to the tangent. Let's just set this one up. Again, do we have a right triangle? Yeah. All right, so what should I write down?
11 squared plus x squared equals 7 squared.
Beautiful. Perfect. And then you could solve from there, probably. So what I want to get to is like 5 and 6. You'll notice these look a little different. That's because I put them in from Delta Math, so you're going to see problems like this. And again, it mostly comes down to reading carefully. So these really need to be carefully read. So let's read number 5. Given circle E, so again, it's circle E. E is the center with a diameter CD. So I have a diameter and a radius EA. So my radius is right here. AB is tangent. So segment AB is tangent to circle E at point A. So we have our nice little point of tangency right there. It says if AD is 16 and EA is 17, solve for AC. We want to figure out the length of AC right here. I don't know the best way to do that. Okay, interesting. What are you thinking? So EA is a radius. It's 17. Are there some other radiuses in this picture? Yeah, CD is the diameter. So I definitely have, so there's like a radius side and then there's another radius side. So each of those is also 17. That's important to recognize, okay? They're all little radii. And then, so CD is a diameter, and if I have a diameter, and I'm seeing this inscribed angle in green there, do you see that inscribed angle? What's that angle measure on that green inscribed angle? 90 degrees. Because we have a diameter, we know that there's 180 degrees outside here on this arc. So that angle is half. That angle is 90 degrees in that green angle there. And we want to figure out this side right here, AC. That's what I'm trying to figure out. What can I do? Do you see a right triangle? All right, we got the yellow side, and then a green, and then a green. So there's our little right triangle. What can we do to solve? $34, okay. Pythagorean theorem, sure. So we should write down leg squared plus leg squared. 16 squared, yeah. Yep, equals 34 squared. All right. There we go. So it's really just deciphering what we're looking at here. 16 squared is 256. I don't know what 34 squared is, though. 1156. And then I'm going to go ahead and subtract the 256. That's right? 16 squared is 256? Okay, just making sure. So I get x squared equals 900, and then the square root of that, 30. Good. All right, and so that is our AC. AC equals 30. All right, so really just looking carefully at the picture, really thinking. Let's look at number 6. Circle E with diameter CD. Once again, we have a big old diameter here. In circle E. Radius is EA, and we have a tangent line, so we have a point of tangency here on AB. If EA is 7, so what did they just tell us when they told us that EA was 7? The radius, yeah, the radius equals 7. Probably a good thing to recognize. And DB is right here. DB is 4. That's just this little extension right here. Solve for AB. All right, so we're trying to solve for AB. We want this length right here, which is part of the tangent line right there. So we're looking for that little tangent portion. And what I know about a tangent line, what do I know about a tangent and the radius that connects the tangent? There's a 90-degree angle right there, sure. So we have another 90-degree angle. And I have this, again, another right triangle. So these two problems are about recognizing where the right angles are. What's the length of ED? 7. All right, so what is the whole orange segment there? 11. And then what is the green segment? Also 7, because it's that radius again. All right, so what can we do to solve? Pythagorean theorem. X squared plus 7 squared equals 11 squared. Let's see, so x squared plus 49 equals 121. I don't know what 121 minus 49 is. Oh, 72. Subtracting 49, I get 72. And the square root of the answer is x equals 8.5 if you round. And it does say, I will caution you, it does say if the answer cannot be determined, click cannot be determined. So possibly you really maybe can't figure something out, okay? But I did try to show you the two that you're going to come across, so it's a little easier to decipher. Okay, so pay attention. I hope you wrote those both down. All right, turn the page, see what else is over here. More tangent lines. These are actually really easy. So more tangent line properties. 2 segments from the same external point. So from outside the circle, if you draw tangents to either side of a circle, those tangents are congruent. AB is congruent to CD all the time. Which is kind of interesting. If a polygon is circumscribed around a circle, then all those sides are also tangents. So again, circumscribed means surrounding a circle. And so if we have all these points of tangency here, what we have are a bunch of congruent little segments here. So here, AD and AF would be congruent. And from this external point B, these segments are also congruent. And then from point C, we have CF and CE, which would also be congruent because they apply this same property that from an external point, 2 tangents to a circle are congruent. Okay. So on number 11, find each value or measure. Assume that segments that appear to be tangent are tangent. So PQ is a tangent line to a circle, and QR is a tangent to a circle. What's our equation?
14x minus 13 equals 8x plus 5.
Perfect. Yep, we have 2 congruent pieces here, so that's our equation, set equal to each other. 14x minus 13 equals 8x plus 5. I'm going to subtract 8x That gives me a 6x minus 13 equals 5. I'm going to add 13 to the right-hand side, so that gives me 5 plus 13 is 18. And divide by 6, I get x equals 3. And what do I need to do for PQ? Plug in the value. So 14 times 3 minus 13, I don't know what that is. 29. All right. Let's look at number 12. I just want to sort of set this up because it's an interesting question. What do you know is congruent?
10x minus 41
Yeah.
equals 4x plus 7.
Good. So right here, we know that ST is congruent to SU, so we can set up an equation.
17 and the other side also.
So we can use this equation to solve for x, but it wants us to find SV. SV is this line in the middle. So we can find x. X turns out to be 8. What do you do from there? Yeah, very good. Since we have tangent lines, we know that we have right angles here. And then, what do I do with the value of x? Plug it back in. So that's 80 minus 41, 39. So if I plug it back in, I see ST is 39 and 17, and then it's the Pythagorean theorem. So if we want to figure out, I'm going to call it y. So 39 squared plus 17 squared equals y squared. So Pythagorean theorem after that. Kind of interesting. And then last one, number 13, find the perimeter of triangle DEF. So DEF is this exterior triangle. I want the whole perimeter. What's perimeter? All the edges. So I have an 11 here. And again, these appear to be tangents. So what's DH? 11. What's IE? 16. What's GF? 9.5. And so the perimeter is 2 11s plus 2 16s plus 2 9.5s. And that gives me 73. Good. Okie dokie. Any questions? All right, so look for those right angles. That is the job today.